Hi, so this is the data network security drone project that I've been working on. This is an ad hoc network of drones asynchronously communicating with each other, and they're autonomous agents, so they're controlling their own behavior. So these two drones are going to fly over this wall, hopefully, or around it, and they're going to drop their packages off at their destination. And they're going to negotiate not running into each other. So these two drones avoid running. And they're an ad hoc network. So each one of these red lines is flashing in and out. That's a network communication that they're making. And a majority of the time, these drones do not run into each other, which is great. So you can see this ad hoc network is quite large near this distribution center where they pick up the packages. And then as they spread out and move along, this drone isn't communicating with anything else, but there's nothing for it to run into. So that's okay. It's going to drop off its thing, and then it's going to come back to this distribution center to pick up another one. So that's overall what this is doing. And then the security risks I'm looking at is what security risks does this network have in it? And the goal here is, of course, to crash some of these drones through bad security things. So one thing we can do is take this jamming sphere here, which is just an area that is jammed, and we can move this in here. You can see these network communications no longer work, and we have drones that are running into each other and exploding and crashing. And this is because they no longer know where each other are because they can't communicate and broadcast the location. And we've got some phones. So these two drones are going for carefully miss each other there. And in this area, the drones cannot communicate, so you won't see any of those red flashing lines. Outside the area, they can. So this network is relatively sparse. Sometimes the drones fail to communicate and end up crashing into each other. So that's what this area is. So how does this work? Well, this is in Roblox, which is a game engine, and it's actually multiplayer, so you can go ahead and play this game right now. Effectively, what we have for each one of these is, I'm going to show a few components here. We have in each one of these drones, if we view this diagonal tone, we can see that this drone here is labeled as a drone, which each drone has a rope constraint to pick up packages. It has a vector force to apply a vectoring force downwards from its thing, and an orientation to orient itself. And then the code is being synchronized into Roblox Studio through Rojo. We've got each drone has a radio and a scanner. It's got a drive control, which is the primary autonomous component of this drone. It's got a package holding component, a goal manager, and a collision tracker, which is when it hits something, it explodes, and we set the color to red. And then remove the drone object. So what we're going to look at first is we're going to go look at the drive control here, which is the most interesting component. This drive control uses a scanner. It has a vector force and an orientation, and it has its own tilt manager, which just makes the drone tilt properly. So it's vectoring its forces correctly depending on what force it wants to apply. And there's a reach target signal. Every heartbeat, it applies the behaviors and then makes the tilt manager update the tilt appropriately. What are these behaviors exactly? We've got a steering acceleration, a floating acceleration, a height acceleration, and a separation acceleration. The steer acceleration makes the drone want to approach its own target appropriately. The float acceleration is literally just a gravity check, so it inverses the gravity. Our height acceleration here is attempting to avoid hitting the ground. So if we go back into this drone scanner and tell it to debug scans on, we can go ahead and visualize what these scans look like. Effectively what this is doing is we are going to go ahead and try and scan ahead of the drone. So we can see we do a scan in front here based upon its desired heights. These front hits get passed into this height calculation, which then applies the steering acceleration on the y-axis to try and avoid hitting the ground. This means that the drones fly over obstacles correctly and other things. And then the last thing that we have is a separation acceleration, which looks for nearby drones and attempts to separate away from them. So we can see each of these drones, it's going to be quite slow. It's searching ahead of itself in this environment and determining hit points so it can vector above things that it's going to hit. And this might include moving parts, other drones. In this case, it's finding the roof of this supply thing, and it is flying above those components as necessary. And so we're going to go ahead and turn off that scanning because it's very slow. So the scanner itself is used in two places. It is used to determine things in front of it, and it also looks for nearby drone positions. And in this case, those drone positions are reported by the drone itself. So this is the network part, the ad hoc network part of this. So every time the radio receives new data, it handles this receiving by looking at the location packet, and it makes determinations on if it should keep this packet or not, and stores an estimated drone location. It also goes ahead and broadcasts its location every moment, and it adds a random jitter. So this is an average of every 10 or 100 milliseconds. It'll send out its location again with an plus or minus 50 milliseconds on that 100 milliseconds. And so when it receives a new packet, it either forwards the packet or it just reserves it back in its knowledge base so it knows where drones are. And then when it's asked, the scanner is asked where the drones are, it looks at its known location. And so when you see in the simulation all of the drones with the red flashing lines between each other, that is what you're seeing, is a visualization of those packets being sent between each other. Overall, the drones have a goal, which is to get it to a new target. When it gets to a new target, this right here is being assigned by the drone itself. It's saying, do I have a package? If I do, get a pickup target and go to it, otherwise get a delivery target. In a more verbose ad hoc network system, you would actually try and transfer these networks through the radio. I did not have time to do this. So what these drones are doing is they're saying, I don't have a package. I need to get to one of these radio pickups. And I will look for those pickups. And then I will pick up a package there. And unfortunately, my computer is being slow, so these drones are hitting into things because that network update rate is much lower. And then once it has a package, it will attempt to get to one of these pink items here. And so that is what it's trying to do. It's looking for a target, and then it's going to it. So just randomly selects that. So future expansions of this project would be looking deeper into those radios. And then overall, we just have this COM network manager, which is running manager, and this is all initialized through server main. So other instances we have is we have a jamming zone here. We've got pickup targets, which is these areas right here. And we've got drop-off locations, which are here. Delivery targets is what I believe what they're called. And so these instances are all instantiated. This is all written in Lua. So we've got different implementations for each component here, which is nice and clean. If you're interested in this code is available on GitHub. There will be a link in the project and underneath the description. Overall, thank you very much.